Now, in this experimental arrangement, we already discussed this thing. C, that is emitter plate, that is the photosensitive surface. When the light incident on it, the electrons are emitted. And these electrons emitted from the emitter plate are collected by this collector plate, that is represented by A. And now here, with the help of this commutator, we can change the potential at A and C. Initially, A is kept at positive potential. It implies that A is connected with the positive terminal of the battery. And then after, with the help of this commutator, we can change the potential. We can connect the collector plate A with negative terminal of the battery. And then after, by changing the potential across collector and emitter, with the help of this rheostat, one can carry out the study related to the effect on current. And that potential difference can be measured with the help of this voltmeter. And now, by changing the intensities of the incident radiation, you can repeat the experiment. Similarly, by changing the frequency of the incident radiation, you can repeat the experiment. Okay? Now see, as shown in the previous figure, the experimental arrangement was made. Then first, for the incidented radiation, the intensity was taken I1 and frequency F1. Now, applying different potentials at collector, the photoelectric current was measured and the graph of photoelectric current versus voltage was prepared. Say, for incident radiation, the intensity is I1. Then at zero potential, the current obtained, that is this much. So electrons emitted reached to the collector and current was constituted in the outer circuit. When positive potential at the collector increased, they observed this thing, the current remains constant. It implies that here all the electrons emitted from the emitter reach to the collector, and collector collect all those electrons, and in the outer circuit the current is constituted. If you increase the voltage, then also the current remains constant. It implies that here this potential difference have no role in the emission of electrons from the emitter plate, just it collect the electrons which are emitted from the surface. Thereafter, when the potential on the collector was made negative and negative potential increased, so they observe this thing, the photoelectric current slowly decreases, and at a particular negative potential on the collector, the photoelectric current becomes zero. That particular negative potential for which the photoelectric current becomes zero, that is called stopping potential. That is called stopping potential. So when the experiment was performed with the radiation having intensity I1 and frequency F1, the observations were as shown in this graph. Clear? Then after experiment was repeated. Now in second experiment, the frequency was kept constant one, F1, but the intensity of the radiation was increased I1 to I2. I2 is greater than I1. And they observe this thing, if intensity is increased, then current also increases. But again, if we increase the positive potential at the collector, then current remains the constant one. Then they observe this thing, when negative potential on the collector is increased, the photoelectric current decreases, and finally at the same stopping potential, the photoelectric current becomes zero. Third time the experiment repeated. Again the frequency was kept constant and intensity increased to I3. Again they observe this thing, the current increases. Here current increases from this to this. If positive potential at the collector is increased, the current remains constant one. But if the negative potential is applied and is increased, then photoelectric current decreases, and again at the same stopping potential, it becomes zero. Then after, the experiments were repeated like this. See, in this first set of experiments, the frequency of the incident radiation was kept constant and the intensity of the incident radiation changed. Then by applying different potential differences across these plates, which type of changes takes place in the photoelectric current were studied. Then in the another set of the experiment, they kept intensity constant and frequency was changed. See, first intensity was kept constant, I1, and frequency F1, this observation. Then after keeping intensity constant I1, the frequency was increased F1 to F2, and they observe this thing, at positive potential the current is the same one, but the negative potential applied and increased, then no doubt photoelectric current decreases, but it becomes zero for the voltage which one is greater than the previous one. Means this stopping potential V02 is greater than V01. Again, by keeping this intensity I1 constant, the frequency increased F3 and the experiment was repeated. Then they observe this thing, the current remains constant one, but when the negative potential is applied, the stopping potential again increases. So in this way, the experiments were performed and the results were represented here graphically. And they finally concluded this thing, the relationship between photoelectric current and intensity of light, that is linear relationship. Means as intensity increases, the photoelectric current also increases. And when the relationship between photoelectric current and intensity of light represented, they obtain the straight line graph as shown in this